right, we're going to take a look at factoring polynomials completely. So what does it mean to fully factor something? Well, in polynomials, it means we want to break it down into its smallest possible factors. Let's take a look at numbers, though, just to see how that all works. Let's say I ask you to factor 24. Now, we could write 24 equals 1 times 24. That is factoring it, but since it didn't change it, I'm not going to write it down. Keep it in mind, though. 24 could be any of those other three options. Well, if I include 1 times 24, all four are correct answers if I ask you to factor 24, but none of them is factored fully. So if we need to factor 24 all the way, here's what we'd have to do. We would start with one of those three options, but then we'd have to keep breaking down numbers until we can't break them down anymore. So in this one, you'll notice 12 broke into 3 times 4, 8 broke into 2 times 4, and 6 broke into 2 times 3. But then we still need to take these and break the 4 down more. And ultimately, we end up at the same answer, a single 3 and 3 2's all multiplied together. So no matter what pathway we took, we still ended up with the same exact answer, because when we fully factor, we break everything down till it can't be broken anymore. So now let's think about how to do this with polynomials. We're going to start with 2x squared minus 8x minus 42. I'd like you to figure out which of these is in factored form and which of these is factored fully. Go ahead and pause the video and do some factoring. Welcome back. Let's see what you came up with. A and B and D are all factored forms. If I put those into a generic rectangle and I multiplied them out, I would get back to the original problem. However, it is D that is fully factored. With choices A and B, like here, choice A, there's still a 2 that divides out of this. That would make it match the first parentheses of B. In B, there's a 2 that could be factored out of this one. That would make it match this second parentheses of A. So you can see that the pieces are all there, but it's D that's fully factored. We need to get it so that it's all the way down and there's nothing left to do. So how do we do it? Well, step one is we always take out the greatest common factor. And I did say greatest, so we have to go for the biggest thing that we can possibly divide everything by. And if the x squared term is negative, then we must make our GCF negative. So in this case, it turns out to be negative 3. So I divided everything by negative 3, and I'm left with 8x squared minus 10x minus 3. So now step 2 is I'm going to go ahead and factor the 8x squared minus 10x minus 3 using our x box. And you'll notice I put some things in color because I want to make sure you know who goes where. So the negative 3 we took out at the beginning kind of hangs out here in the corner. We're not going to deal with it. It's the 8x squared that comes here, the minus 3 that comes here. We multiplied those to get negative 24x squared, and we're looking to add to negative 10x. So there's our magic pair transferred over, and then I was able to take a 2x from this row, and that left me with 4x, negative 3, and 1. So there's all my factoring. Step 3 then is to write out the final answer with all the parts. It's that original negative 3 that we took out at the beginning that was just hanging out in the corner, and then it's the 2x minus 3 from the left dimension of our box, and the 4x plus 1 from the bottom dimension of our box. That is the fully factored answer. So remember, a problem that wants just factoring has no equal sign in it. That's because it's just an expression, so all we can do is break it down. We can't solve anything if there's no equal sign in order to say, hey, solve for what it equals. When we do our x box, our x squared term that goes in that lower left must always be positive, because then our x variables come out always positive in the final parentheses. If for some reason our x squared term is coming out negative, or the x variables in our box are coming out negative, we either need to take out a negative greatest common factor, or we need to adjust. Remember, it's not the x variables in the dimensions of our box that will be negative, It'll be the plain numbers. So now your job is to go ahead and pause and see if you can fully factor each of these 4 problems. Welcome back. Here are the answers. So on the first one, we take out a negative 10, and then x squared minus 25 becomes x plus 5 and x minus 5. On the second example, we took out a 4, and then we factored x squared minus 11x plus 18. On the third, we took out a negative 3, but then x squared minus 2x minus 2 can't be factored anymore, so that's actually all the way done. And on the third, the fourth, we take out a negative 2x, and then we factor it down. Hopefully this helps clear up some of the challenges you've been having with factoring fully. I hope that you're able to transfer these skills to something else coming up.